In this video, I'm going to talk about how to take the derivative of trig inverse functions. I hate memorizing rules, so I think it's best to just do these by definition. Y equals the sine inverse of 3x, and we want their derivative. So if we interchange these two arguments, then we can drop the inverse. For the record, if we interchange these two arguments, since there is no inverse, now we have to introduce an inverse. But we don't want to do that. With respect to x, the derivative of the left side is 3. With respect to x, the derivative of sine of any angle is the cosine of the angle times the derivative of the angle, which is dy dx. Solving for dy dx, we get that dy dx is 3 over cosine y. And if you like, you can write this as 3 secant y. But nonetheless, however you write it, you'd like dy dx to only be in terms of x. But as you can see, it's in terms of y. Well, this here will give us a way to convert y's to x's. We know that the sine of y is 3x over 1. Remember, 3x is the same as 3x over 1. So then this side must be 1 minus, it must be this squared minus that squared, square root. But now things become easy. Secant is this over that. So it's 1 over that. And there's your answer. I would just say what 3 times 1 is. Don't have to memorize, 25 different rules. If you have that y is equal to cosine inverse of the square root of x, then the square root of x is cosine y. The derivative with respect to x of the left side is 1 over 2 square root of x. The derivative of cosine of any angle is negative the sine of the angle times the derivative of the angle with respect to x. Solving for this, you get that dy dx, because that is what we want to solve for. Dy dx is negative 1 over 2 square root of x sine y. Square root of x sine y. This answer is 100% correct. But most probably, your instructor would want you to write it only in terms of x. So we use this. Y is the angle. How do I know that? You take cosine of angles. And remember, square root of x is the square root of x over 1. So the cosine of the angle is adjacent over hypotenuse. This side's going to get this squared minus that squared. Okay, now I know the sine of y. The sine of y is opposite over adjacent. So it is 1 over 2 square root of x times the sine of y, which we just learned was the square root of 1 minus x. And there is your answer. If you're told that y is equal to the cosine inverse of 1 over x, well, and you want the derivative with respect to x, interchange the arguments. 1 over x is cosine of y. And remember that 1 over x is x to the negative 1. So the derivative is, bring down the 1, make the new power 1 less. So it's negative 1 over x squared. Negative 1 over x squared. And the derivative of cosine of any angle is negative the sine of the angle times the derivative of the angle with respect to x. If two quantities are equal, you can change your signs and they'll still be equal. Okay, so dy dx is nothing more than 1 over x squared times sine y. Well, this here is going to give you the sine of y. We know the cosine of y is adjacent over hypotenuse, 1 over x. This is going to be the square root of this squared plus that squared. Oh, the sine of y is that over hypotenuse. So it is 1 over x squared times the sine of y. The sine of y is the square root of x squared plus 1 over x. So in the end, since one of the x's cancels in the top and the bottom, there's my answer. Suppose you were told that y is equal to secant inverse of 4x. In the change, 4x is equal to the secant of y. Okay? The derivative of the left side is 4. The derivative of secant of any angle is the secant of the angle times the tangent of the angle times the derivative of the angle. So then dy dx is 4 over the secant of y times the tangent of y. So let's deal with this equation right here. Just remember that it's 4x over 1. The secant of y is the hypotenuse over the adjacent 4x. And the other side is going to be the hypotenuse squared minus the other leg squared. So this is 4 over, I won't do the reciprocals yet. That is, the secant of y, well, you can get it from the triangle, or you can say, oh, that was given. Times the tangent of y is this over 1. Oh, so it worked out nicely. And then I would just say that the 4 is reduced to 1, and you get 1 over the square root of x times the square root of x squared, take away 1. Okay, there's your answer. It is in terms of x. This is perfectly correct, but it's not in x, in terms of x. Let us try this one. What if I told you that y is equal to the sine inverse of x plus 2? So now, you can't interchange those two because those are not their arguments. The arguments are y minus 2, I brought the 2 over, and x. Those are the arguments. These can be interchanged. X is equal to the sine of y minus 2. With respect to x, the derivative of x is 1. The derivative of sine of any angle is the sine of the angle times the derivative of that angle, which is 1 dy dx. So, dy dx is equal to 1 over the sine of y minus 2. And we'd like to get it in terms of x's. Oh, the derivative of sine of any angle, is the cosine of the angle. Sorry. So this should be the cosine of y minus 2. Well, this tells us that the angle has a strange name, but whatever. The sine of y over 2 is x over 1. So it's opposite over adjacent. This side always gets that squared minus that squared. Okay, well, the cosine of this angle is adjacent, which is 1 minus x squared divided by 1. The rule for dividing by 1 is don't bother. So there is your answer. There is your answer. Bring the 2 over. It has to be to swap this and that, if I can call it. It has to be in this form. Nothing else. No plus 2. Then you can say that the sine of the square is equal to the triangle. Let us look at this one. Y is equal to x times the tan inverse of 3x plus ln of 1 plus 3x to the 4th. So the derivative is going to be the derivative of this plus the derivative of that. The derivative of that is easy. You put the 1 plus 3x to the 4th on the bottom, and its derivative on top, and that's done. But here we have a product. And when you take the product, when you use the product rule, at some point you're going to have to take the derivative of tan inverse of 3x. So let us do it on the sine. Sorry. I'm going to call it y equals the tan inverse of 3x, but don't confuse it with that y. It's like a separate problem. So 3x is equal to the tangent of y. The derivative of 3x with respect to x is 3. The derivative of tangent of any angle is secant squared of that angle times the derivative of the angle with respect to x. So divide the left side by secant squared y, but that's the same as multiplying the right side by its reciprocal. So we get 3 cosine squared y is equal to dy dx. And we just have to find out what cosine squared y is. And we use this here. The tangent of y is 3x over 1. This side is going to be that squared plus that square, square root. So the cosine of y is 1 over that. So cosine squared y will be this squared, which is this. So we get 3 over 9x squared plus 1 is the derivative of tangent 3x, tan inverse 3x. So up here, product rule. So derivative of the first, which is 1, times the second function, plus the first, times the derivative of tan inverse of 3x, which is 3 over 9x squared plus 1. 3 over 9x squared plus 1. Plus the rest. Well, 1 times that is just that. 3x plus x times 3 over 9x squared plus 1 plus 12x cubed over 1 plus 3x to the 4th. And that's the answer for that problem. Let us finish with this interesting problem. Y is equal to the sine inverse of x plus the cosine inverse of x. That is, y is equal to y1, that is, I'm calling that y1 plus y2. Now, one way of doing this is when you take the derivative of a sum, it's the derivative of the first function plus the derivative of the second function. So, let us find out what each of these are. Leave a little space. So y1 is sine inverse of x. That means x is sine of y1. The derivative, so dy1 dx is 1 over cosine of y1. Well, we use this equation to learn that the sine of y1 is opposite over adjacent. What goes on the other leg is this squared minus that squared square root. So the cosine of y1 is this over 1. And you don't have to bother with dividing by 1. So that is the derivative of y1. Now, y2 is cosine inverse of x. That means x is cosine of y2. That means the derivative with respect to x of the left side is 1. The derivative with respect to x on the right side is negative sine of y2 times the derivative of y2 with respect to x. So dy dx here is negative 1 over the sine of y2. Using this here and understanding that x is being divided by 1, the cosine of y2 is adjacent over hypotenuse. This squared minus that squared goes on this side, but with a square root sign. So we get negative 1 over. Now the sine of y2 is opposite over adjacent, which in this case is just the opposite. Okay. So let us see what we got. y1 prime was this 1 over the square root of 1 minus x squared plus y prime 2. The derivative of y sub 2 is that. Well, adding a negative is the same as just subtracting. Ooh, we got 0. If the derivative of something is 0, if the derivative of this is 0, the derivative of this is 0, then this must equal to a constant. Interesting. Let us see if we can find out what that constant is. So y is equal to sine inverse of x plus cosine inverse of x. Well, let us call that theta. Well, what we know is that the sine of theta is x over 1. That is, I am saying that the sine inverse of x is theta, but that means that the sine of theta is x. Okay. Fair enough. Now, if we know that that's a right angle, and the other two angles must add up to pi over 2. So this must be pi over 2 minus theta. But look at this. The cosine of this angle is also x. The cosine of that angle is also x. That is, this here is pi over 2 minus theta. Because now I can call it theta. Theta is the cosine inverse of x, and the cosine of angle beta is x. But that's pi over 2 minus theta. I hope this is clear. And then, let's write it down more formally. So, like I said, that's theta plus, and this here is pi over 2 minus theta, so we just get pi over 2. That is, if y is equal to sine inverse of x plus cosine inverse of x, that means y is equal to pi over 2. And if y is a constant, then dy dx, or y prime, is 0. And that is what we got as the answer. And this completes the video on derivatives of trig functions. In my opinion, don't memorize the rules, because in a couple of years from now, if not in a couple of months from now, you're going to remember the rules. I do not remember the rules, but I can still take these derivatives because I know how to take derivatives, and I know that all you do is switch these. That's the definition of inverse. And I just take the derivative of both sides. I get my answer in terms of y, and then one of the equations helps me convert y's to x's. This is it here. It converts trig functions of y's to x's. Because anytime I take a trig function of y, I'm dividing two sides. Whether it's this over that, or that over this, or this over that, they all involve x's. So I can convert cosine y, secant y into x's.